Good morning, students. Today we are going to see the biogas technology. So this part you already studied in our last semester. So first I would like to review something or recall something that we studied in our last semester, and then we can see some more topics which is you didn't studied in your last semester. So first is biogas technology. Biogas technology means basically it is the process which is involved in the biogas technology is anaerobic digestion. As the name indicates, the anaerobic digestion is a process of biomass digestion undergoing in the absence of air, that is in the presence of microorganism which does not require any oxygen to live on. They will make the oxygen by digesting the material of digesting the substrate that what they get. So anaerobic digestion involve the microbial digestion of biomass, so organisms that can live and grow without air oxygen, and that will get they will get the oxygen by decomposition of the matter which is containing it. So the process is basically taking place in a temperature up to 65 degrees Celsius, and that is the mesophilic range. Sometimes it may also happen in the thermophilic range, that is uh, means 7 up to 75 degrees Celsius, and it requires high moisture level, max minimum of at 80 percentage of moisture. So the after the anaerobic digestion, the product is formed as the biogas, which is a mixture of mostly methane and carbon dioxide with some amount of impurities like ammonia, hydrogen sulfide, etc. So the methane can be directly burnt, or it can be upgraded to synthetic gas by removing the carbon dioxide and other impurities. So, and after the process, the what we get at the outlet of the biogas plant is the slurry, that is a digested slurry, which is rich in protein and can be used as an animal feed. And after treatment of the effluent, we can use it as we can return back to the soil as a soil conditioner or organic fertilizer. So biogas, that is a product of anaerobic digestion, is a combustible gas of a calorific value of about 25 megajoule per meter cube, and it is a mixture which contain methane, which is a combustible major combustible constituent of the biogas, which contain almost 50 to 75 percentage. Next is carbon dioxide, that is 24 to 45 percentage. Next major constituent is water, 2 to 7 percentage. Then nitrogen and oxygen, which is less than 2 percentages. Then ammonia, hydrogen sulfide, all are contained less than 1 percentage, and these are the combustible part, and these are the incombustible part. That is, these are the part which contribute to the calorific value. So biogas generation is the process is called anaerobic digestion, and it is we discussed that it is occurs in the absence of air, usually in a temperature of 35 to 70 degrees Celsius, and it is taking place in a digester, which is container, which is known as digester, and it is having three phases. That is hydrolysis, acidogenetic phases, methanogenetic phase. So we can discuss one by one. Firstly, the non-soluble and partially soluble compounds of biomass material is converted to soluble organic material, and that will simpler. Complex material is become simpler material by the enzymatic activity, and the process is called enzymatic hydrolysis. Later, the what products which is formed in the hydrolysis, that is a soluble organic compound, will again acted upon by the acidogenetic bacteria to form volatile acids and carbon dioxide, and the process is known as acidogenesis because in this process we will get acids. So formation of acid is called acidogenesis. Next, the products which is formed in this process, that is a volatile acid, is next acted upon by the methanogenetic bacteria to form methane. So since the process is the formation of the methane, it is called methanogenesis process. Next is the operation of biogas plant. To till the last slide, we already studied in our last semester, and this part we are going to study as a new in our now current semester. So operation of biogas plant is very much important because the proper operation and proper working of the biogas plant only we will get proper output of the gas. Otherwise, it will not work properly, and the gas outlet will outcome will not be proper. It will be intermittent. So before knowing the going to the installation of a biogas plant, the owner should be know how the process is working both theoretically and practical way. He have to be well acquainted with the system. So that if we are maintaining the operation and if we are following the correct procedure for to in a biogas plant, it will be require less expense to maintain, and it will be run for a long time without any much repair. So the basic thing for a proper working should the operator should know, or the owner should know the proper working and how to maintain, how why the fault is happening. All those things should be known by the operator. So before starting the biogas plant, first we are can starting the biogas plant, then operation of the biogas plant, then maintenance of the biogas plant. First we can go to the commissioning of the biogas plant, that is the starting of the biogas plant. It includes four steps. That is, after the construction of the biogas plant, we can go for the inspection and the final acceptance of the all components. Components include digester, gas holder, gas pipes, valves, inlet, outlet, etc. Then initially we have to fill the biogas plant, the starting the biogas plant, then user familiarization. So first is the inspection and final acceptance. So the proper working of a biogas plant is basically depend upon how effectively the plant is designed and how effectively we planning the planning is taking place before the starting of this biogas plant. So, after the complete construction of the biogas plant, we have to check any leakages there, especially for all the parts like digester in case of leakage, gas holder whether it is leaking or not, gas pipe whether it is leaking or not. All those things we have to check properly, and we have to check whether it is constructed with the designed dimensions or not. So for the leakage test, for the digester, especially the cement masonry digesters, we will use the water sealing test. So water seal test including first we have to fill the biogas plant up to complete saturation, means up to the complete level. Then all part like including the digester and gas holder we have to fill completely with the water. Then we have to wait some time so that all the parts become saturated in water. So some time in sense means we have to wait 1 day so that all the parts is completely saturated. After 1 day, so there may be some level difference in the water, then after because some water is absorbed by the parts to become saturated. After 1 day then we have to wait, and then we have to see, uh, we have to refill the water to the initial level. Then the next day also we have to see and check the water level. If the water level, that is water loss in the next day, is greater than 2 percentage of the total digested volume, that means there is some leakage in the system, and we have to find out whether at what point the leakage is there. And if the water loss in the next day is less than 2 percentage, then we can ensure that the digester is leak tight. This is how the water seal test is progresses. Next is the gas seal test. This is especially taking done for the checking the leakage of the metal gas solder or floating gas solder. So in that, first, as the gas seal test, we will first fill the biogas plant digester with the gas, and then uh, first we have to hold the digester in the proper position, and then we have to fill the gas in the side, and we have to close the gas valve also closed condition. Then we can fill the gas solder with the gas. Then we have to mark the at what level the gas solder is standing in the digester point. Then we can mark that point, and the next day we can, for second day we can see. And if the gas solder is blow means move down more than 1 to 3 centimeter, it is more than move down more than 1 to 3 centimeter, that means the gas is leaked from the system. Then only the gas holder will be moved down, right? That means uh, so there may be some leakages, and that leakages can be checked using the soapy water. So that is about the gas seal test. Next is the pressure testing of the gas pipe. After testing the digestion and the gas solder, we can go for the testing of the gas pipe. The gas pipe connections are properly made, and then we can give pressure to the pipe either with the aid of a pump, or with then otherwise we can placing the weight on the gas solder. So after sometimes if there is no noticeable gas loss, at least for 1 day, then we can consider that the pipe is gas tight. So that is the final inspection and final acceptance of the uh, biogas plant. After that, we can go to the initial filling of the plant. We know that the biogas is the process that is methane formation. So that may include the favorable microorganisms. So first thing that we have to kept in mind, we have to feed the favorable microorganism into the system for proper biogas formation. So we can use digested slurry from any other plant, or you can use cattle dung which is rich in methanogenetic bacteria. So that process is called seeding, and it is advisable to collect the biogas or slurry or the cattle dung before the construction, before the starting or during the construction phase itself. So that is the initial filling of the plant, and during the initial filling we can give add more water to the substrate than the usual. Usually we will use to fill the substrate and water in a ratio of 1 is to 1. So initially we can add some more water, and in initial stages the gas productions will be intermittent, because after some time, some day only, we will get a continuous gas supply. Before that it will contain more, we have to open, we have to allow the gas, some of the gas to leak out, because the initial stages the gas will be low quality biogas containing more carbon dioxide, and which will be very odorous in biogas. Then erratic gas production will be there. So depending upon the feed material or substrate that we use in the biogas plant, the number of days after which the biogas production stabilizes maybe changes. And if we are using a cow dung, then the good yield of biogas productions can be achieved within 2 to 3 days of the initial starting of the biogas plant. The next point and the last point in starting of the biogas plant is the user familiarization. So that we already said in the first slide, it's in first session itself. So the owner should be familiarized with the details of the plant, both in theoretical and as well as in the constructional way, then also the practical way. So he knows the constructional details of the plant, he knows the process which are to be taking place inside the biogas plant, not only in theoretical way, but also he had to be get maximum acquaintance with the practically. We have to give him training in much practical way, for using all parts of the plant. Then only he can properly feed the plant, properly maintain the plant, and we'll get only we will get a proper output from the biogas plant. So that's for today. The next part, that how we are to go for checking or of maintenance of a biogas plant in the next days. Thank you.